Alright guys, this is a review for Chapter 2, The Nature of Molecules and the Properties of Water in your textbook. So I'm going to move over to Chapter 2 so I can pull out some things that will definitely be on your exam on Monday. Prepare you guys. Okay. Properties of water, nature of molecules. Alright. All matter is composed of atoms. There are 3 subatomic particles of an atom. You have your protons, neutrons, and electrons. Okay? So here you have them. As you can see, protons, you definitely need to know the 3 parts for your exam. The protons, of course, have a positive charge. The neutrons have a neutral charge, and your electrons have a negative charge. And they orbit the nucleus. The electrons are not inside of the nucleus, so they're found in orbitals which are outside of the nucleus, so they're kind of circling it. The protons and neutrons, on the other hand, are inside of the nucleus. And here, this picture is in your textbook on page 22, where they're actually showing you, we know hydrogen has only 1 proton. The atomic number is 1. So inside of your nucleus, you have that 1 proton. And also, if you look at oxygen, oxygen has protons and neutrons. Neutrons and protons, well, neutrons are neutral, so both the protons and neutrons are inside of your nucleus. Okay, the atomic number I think is on your study guide. The atomic number, the number of protons equals the number of electrons. As we were doing the electron shells, I'm sure you guys noted that I was saying, okay, the protons are going to be equivalent to your electrons. So the protons, which is in your periodic table of elements on page 26, for example. If you look at lithium, which is Li, the number at the top is which is 3, is the atomic number, and also I think lithium was one of the elements I put on the board that you guys had to complete in class for quiz grade, has also 3 electrons. So on the first shell you're going to have 2, and on the second one you're going to have 1. So atomic number is the number of protons. Mass, weight, it's called the atomic weight or the atomic mass. Both the protons and your neutrons. I don't think that's on your study guide where you actually have to know that. A cation and an anion. Interesting enough, we know that cations has a positive charge. So why do cations have a positive charge? Because they have more protons than electrons. Let's take sodium chloride for example. Look in the periodic table of elements on page 26 and find Na for sodium, and it's to your far left, and if you look at the number at the top, sodium has 11 electrons. We did this when we were talking about an ion. You know, of course, an ion can either accept an electron, and of course it can donate an electron. In this case, sodium has 11 electrons, 2 on your first shell, 8 on the second shell, and 1 on the third shell, which makes it have 11. So because, remember, protons and electrons will be the same number, you're going to have 11 protons and 11 electrons. Now remember, we lost that last electron on that third energy level, so that made it have 1 less electron, which made it 10 electrons, but it still maintained its 11 protons. So because it maintained the 11 protons, there were more protons than the electrons. 11 is greater than 10. So, of course, you know, it's going to pick up a positive charge. An anion, on the other hand, when we looked at chloride, which is Cl, the number of electrons for chloride, Cl is 17. Remember, on the first shell, there were 2. The second one, there were 8. And the third one had 7, right? So it picked up that additional electron from sodium, which made that third shell have 8. Okay, so when that third shell picked up 8, that meant that chloride had more electrons. Now it has 18 instead of 17, but it still has what? 17 protons. So it has fewer protons than electrons. 17, of course, is less than 18. So because it has more electrons, an anion will always, guys, have a negative charge. Okay? No orbital can contain more than 2 electrons. Okay? Electrons, they circle the nucleus. Like I said, they are found in what you call orbitals, where they're found circling the nucleus. They're actually attracted to the protons, which have a positive charge, which is why they're circling the nucleus in orbitals. Okay, a valence electron, I don't know if this is on your study guide or not, but that's the number of electrons in your outermost energy level. Those that will not react, they have all 8 electrons. So let's take, for example, neon. Okay, if you look at that far right column, you have helium, neon, argon, krypton. Those are called noble gases. All of those are going to have 8 electrons in their outer shells, which means they're not going to react. Okay, they're going to have the maximum number of electrons. So the number of electrons in the outermost energy level is called a valence electron. So let's take helium, for example. Helium has, in its first shell, has 2 electrons. We know the first shell you can have up to what? 2 electrons, which is fine. That's considered the outermost energy level for helium, which makes it a valence electron. Let's take neon, for example. Neon has 10 electrons. Now, on the first shell, it can have only 2. The second shell, it can have up to what? 8. Okay? Now, this one is called an inert element or a noble gas because it has 8 electrons in that outermost shell. The second level is not going to react with any more elements, and it's also going to fulfill the octet rule where the outer shell is completely full, which has what? 8 electrons in this case. So that's a great example. Valence electrons are just electrons in the outermost shell. It could be any number. The octet rule simply means there's going to be 8 electrons in that outermost shell, which makes it stable and non-reactive. Okay, so if you look to the far left, like I said, those are your noble gases in the periodic table, and I just did neon for you. If we do argon, which has 18 electrons, the first shell will have 2, the second one will have 8, and the third one will have what? 8. Right, so 2 plus 8 plus 8 will give you what? 18, okay? Because that third shell, you can have up to 8. Even if you have a fourth energy level, guys, you can have up to 8 as well. But just remember that first shell, you can only have 2 of them. So argon is stable. Why? It fulfills the octet rule. Why? Because it has 8 electrons on its third energy level. And of course, the valence electron for argon is going to be 8 because there are 8 electrons in that outermost shell, or the third shell. Now, there are 92 naturally occurring elements. The most common ones are carbon, hydrogen, oxygen, nitrogen. Phosphorus and calcium are 2. These are the ones that make up the bulk of the body weight of us, 96.3%. Okay, moving on. I don't think you have to know. We did go over some examples of a molecule, and Yeah, we did go over the molecule. I don't think you have a molecule on your test, but we did go over some examples. We're getting ready to talk about chemical bonds, and of course, chemical bonds form between both molecules and what? Compounds. Okay, let's look at an ionic bond, which is very, very important. So let's look at an ion. Okay, ions can gain or lose an electron. Okay, that is an ion. But so we took sodium, as I gave you the example earlier, lost an electron. Chloride, chlorine gained an electron. So those are opposite charges. They're going to what? Attract each other. So when you gain or lose an electron, or I like to say if you accept or donate an electron, it's going to form an ionic bond between those two compounds. Ions are associated, they have charges associated with them. So they have different charges, like a positive or a negative charge associated with them. Okay? So remember, they can donate electrons and they can accept electrons. Ions can. Great example here. I've already talked about it with sodium having the electrons. In order for it to become stable, sodium forms an ion with a +1 charge. Okay, so sodium is going to give up that electron in the outermost shell, which is here. Okay, and once it gives up that electron, of course, it's going to have 2, 4, 6, 8, 10 electrons, 10 protons, 10 electrons now, but it's still going to have the 11 protons, which means it's going to have a +1 charge because it still has an additional proton. All right. However, sodium chloride, of course, is going to gain that additional electron. As you can see, there is 2 on the first shell here, 2 here, 2, 4, 6, 8 on the second energy level or shell, and you're going to have 2, 4, 6, 7 here on that outermost shell, but it's going to what? Gain this additional electron from sodium. Now it has what? Instead of having 17 protons, 17 electrons, it's going to have, it now has, 2, 8, 17, yeah, now it has 18, because it has 8, 2, 4, 6, 8, 8 here. So now it has what? More electrons. So it has, chlorine has, now has 18 electrons, but it only has what? 16 protons, which means it's going to have what? A negative charge. Covalent bonds. It's just the sharing of electrons. When atoms share 2 or more valence electrons, the strength of the covalent bond depends on the number of shared electrons. Okay? Let's look at an example here. Very, very simple example. Hydrogen, for example, only has 1 electron. Periodic table of elements, you find hydrogen to your far right, far left at the top on page 26. You only have 1 electron. But on that first shell, we need 2, which means it's going to pick up another hydrogen electron. Now they're sharing, which is why they're overlapping. So now they're sharing what? 1 electron, and a single covalent bond is going to form between these 2 hydrogens here. oxygen, the number of electrons for oxygen is going to be 8. You only have 2 on this first energy level, and you have 6 on the second one. But remember, we need 8, right, to make it stable. So we can bring in another oxygen. It's going to bring in these 2 electrons here. They're going to overlap because remember they're sharing. Okay, now both of them have 8 because they're sharing what? 2 electrons. When they're sharing 2 electrons, a double covalent bond will form between oxygen. A triple covalent bond, nitrogen for example, the number of electrons is 7. 2 on the first shell. It's going to have 1, 2, 3, 4, 5 on the second shell, but it needs 3 more to be stable. We bring in another nitrogen, and of course they're going to share these 3 electrons here, making it a triple covalent bond. Hydrogen bonds, on the other hand, they're formed in water molecules. Okay, they're polar. The oxygen is more electronegative, and the hydrogens are more electropositive. So electropositive hydrogen from one polar molecule is attracted to an electronegative atom that is often what? Oxygen. Okay, so we're going to have hydrogen bonds here. If you look here, this is what that's referencing. So hydrogen has, as you can see, a positive charge. This symbol means the lowercase for delta. It has a positive charge. This oxygen here has a negative charge. So the hydrogen bond is going to form between this positive and this negative charge of this oxygen on 2 separate water molecules. Okay, that's what's going to actually hold the water molecules together. You can also have another organic molecule that it can bind to. Say, for example, I think I put nitrogen on the board, where the N right here had a negative charge, which is going to be attracted to the hydrogen, which has a positive charge. Or it could be DNA. We're going to learn later this semester that DNA also, a hydrogen bond is going to also form between the DNA double helix that's going to hold the 2 strands together. Here are some properties of water that I'm going to talk about a little bit later. So to finish up this chapter, I'm going to talk about the properties of water, and then I'm going to talk about acids and bases, and I think that will be it. Yeah, that will be it. Another really good example before I end this of a, I'm trying to think, yeah. Salt and sodium chloride are held together by ionic bonds. Okay, you guys will understand that. Okay, so this one is 18 minutes long. I'm going to end this recording because it's time for me to come